Is there something like that, like a good tech debt?
For me, it's kind of easy. It's the cost for all the choices you've made in order to make faster progress. Yeah, exactly. But it is from the business point of view, it's not really necessary.
They don't bring much of the return of investment.
If the code is running, has no bugs, but is really ugly to read, then it's not really important to refactor it, right? I'm a big fan of doing this incrementally, so not doing this big bang refactoring and refactor everything. To what degree does it make sense to refactor this? Let's start with the most important things or the most valuable things.
How do you measure the tech debt in your code base or in your technical product?
First one, what we do is kind of a hotspot analysis, right? So when you look at tech debt, right, it's all about slowing down changes or slowing down future changes.
All right, so we are up. Hi, Sebastian. It's very great to have you here on the pod today.
Yeah, thanks for having me here. It's lovely.
Yeah, so today we are going to talk about the technical debt in the organization and all things around it. What it is, how do you solve it, how do you manage working with the code base, with the technical debt and things like that. So I'm really excited to talk about this topic, which is very relevant to many different organizations and many different team leaders. Before we do that, and I thought that it might be nice if you give us a short introduction about yourself and about your story, especially as its intersection with the technical debt, how it happened that you are so interested in a way in this topic.
Yeah, thank you. Yeah, you will see, when I was preparing, I really saw that I had a lot of touch with tech debt. So, my journey, it started almost 30 years ago when I got my first computer, right? So, and it really made me curious about doing some programming stuff there. And then, I taught it myself, right? It was in the time when internet was not so common. So I had to buy some notebooks, right, and learned it. And this helped me then during studies to get my first professional job in software development. And I worked for a small company. Today would say more it was a startup, but to create software for dentists. And I had one pivotal point there. And this was for me like when I had to go to the customer, because I had all my technical stuff done, and then I talked to him, and he had just a different opinion on what he wanted to see there. But this was really sound for me and super interesting what people do with the technology, and so I stick to through this through my whole career, and then I moved because of this to IT consulting in Frankfurt. I slipped into financial industry. And then my first two projects, and if I now think about it, back then were all about handling tech debt, because it were big migrations of data integration projects, and so this was great learning. I made my way there to project management again, like dealing with people. And at the end of this time, I thought I'd like to go back to the north. Right, this job was in Frankfurt. I come from Hamburg, northern Germany, and I went to the great city of Quickborn. It's here in northern Germany. It's pretty small, but it was the headquarters of Comdirect, which still is the digital daughter of Commerzbank, which is the second largest bank in Germany. And there I learned, tech debt from very many perspectives, right? So they run their own data center. So it was not just code, it was also, some old hardware we replaced, cables and so on and so on. And then on the other side, there were those very, very big compliance products which touched the whole company. It was a very interesting time, but I always had an eye to the new things. I like to do new things. And then I had the chance to switch to the innovation management department there. I got in touch with startups and during a program where, new companies were able to test their products against this big customer base of Comdirect. and it was also super interesting for me to see how they work, what their problems are different. And then moved on to even more management stuff. I would say even, I moved a little bit from tech to people because I worked in digitization for a wealth manager in Hamburg. And this was interesting because it was not so much about the technology anymore. It was there, right, to solve their problems. It was more about getting the people to work with this technology. So I would say they didn't have tech debt. They had just, no tech at all, right? They had tech that's not really how we see it now today. Yeah, and now I work for Corify here and have all the responsibility for all the people who work with technology and the technology itself. And I have a very different view on this topic now, since we are developing a product and, we are a young company. So you still have to find a good balance between keeping a good track, maintaining the speed. But on the other side, of course, we want to grow, right? So yeah, good balance here. So to wrap it up, I saw it from very different perspectives, from a developer, even I was junior, then from the project management or consulting side, where we have a different view on this, right? You just want your projects to be done. So tech debt is more like something, you accept. And now totally different view again.
Right. That it's a interesting intersection of the work experience in corporate world and in the startups ecosystem. And by the way, when I think about it, it's I think, when we talk about the tech debt, really banking and finance is one of the very fertile grounds when you can, learn how to deal with it, because, they got, digitized so early, and, they deal with, important information, sensitive information, financial data. So they have a lot of those, old systems, even written in COBOL, things like that. And they are still working and making money, right? So
yeah, you're right.
Yeah. So going into this topic of the technical debt, I think that one of the things that we could do at the very beginning is to try to define the term and, let our, viewers or listeners know, how do we define tech debt? What do you have in mind when you think about tech debt? What it is for you?
Yeah. You will find a lot of definitions out there, but so it's good, right? So for me, it's kind of easy. It's the cost for all the choices you've made in order to make faster progress or reach your goals faster. Sometimes it's difficult to differentiate between tech and product, and so for me it's really just the tech side, right? It's just like skipping version updates or skipping some test coverage in order to reach your timeline. But what I don't see there is all the functional debt, like that you intentionally remove some functionality in order to meet the deadlines, to find a differentiation there. So this is tech debt for me. And one other thing which you should, because you should handle differently, or you see it differently outside, is that tech debt is something you can do intentionally or unintentionally, right? So unintentionally is more about, it's bad code, right? Or and this is not like real managing tech debt. It's something you have to manage in the teams to bring them forward. But this intentional decisions, this is what I define as tech debt. Like really using it in order to be faster on the market.
Right. So that's an interesting thing. I think it's early maybe 2000, there was this article by Robert Martin, aka Uncle Bob, and he discussed this thing, I think, which is pretty much in line with your definition. I think he sort of said that there is a tech debt, which is the result of the conscious decision that you're gonna sacrifice quality or the correctness for the sake of speed. And the other thing is you did something wrong or something which is incorrect because you just didn't have an experience. And you are, as you mentioned, unconscious debt in a way, right? Or, inadvertent debt and inadvertent, tech debt. So the latter, he called just a mess, right? So he defined it as a technical debt, as something that is consciously being done. Now, we may put those, because that's about the semantics. But from what you are saying, especially as you mentioned these, sacrifice of correctness in order to get some speed, it's sort of in line with the business thinking. When you are running business, you often need to do some sacrifice, and in the world, especially in the startups, when you have a finite resources, being time, money, or whatever, you need to make some choices. What is more important? So it sounds like in case of the conscious decision, it's like there is some value in the tech debt, right? It's like, you take some debt, but it's perhaps something that is at the end, something that is a reasonable choice. So could you tell, me a little bit about, how do you differentiate between this good and bad tech debt? Have in mind some sort of classification when you look at the code base and you see like, this is something where we consciously do that and we know that we need to sort it later, and this is something where we just made a lot of mess and we have to deal with it.
Yeah, that's a good question, right? Whether we take that or not, and this directly leads for me to the question: how do we measure tech debt, right? And to the question of return of investment, and to answer this, right? I don't see that there is a real number you can put on tech debt where it says, right, we have 5 years or so. What you can do with tech debt, if you have to do this immediate decision, right, what we are talking about, this is not about maintaining, it's more about can we do this? Can we sacrifice this in order to for this time, to deliver faster? And I think this depends highly on the estimation and the effects, and it is about translating this debt to business impact, right? So what does it mean for the future? If this helps us now, right, then we gain this, but we lose this in terms like of velocity or stability of the system. So we can put at least a number for this and how much it costs us to fix this later. So and once you have those two numbers, right, what does it help us now? What does it bring us from the business side? And how much does it cost us from the tech side to fix it? Then you can do the calculation. So this is done in the situation where you have to think about can we take this tech debt for now.
Right. So it's from what you're saying is putting this into the business mindset is very much first of all, it's a business decision. It's a trade-off. And the second thing is, contrary to the, I think, maybe not a popular belief, but it's the word technical debt or the phrase technical debt is sort of negatively charged. But from what you're saying, it doesn't have to be in all the cases. It's just a trade-off that you make to bring the business results.
Yeah, and also what we phrased as bad tech debt, right? This is not always intentionally, right? Maybe the developers don't have the skills right now, but what also is often the case that you don't know enough about the product or about the business, so that that you maybe choose in extreme cases the wrong architecture, but still in the moment you made the decision, it was a good decision. So it's more it more shows that you have learned more about the system. Right. So yeah, to be honest, I don't see only a very small amount of tech as real debt, like someone really did something wrong because of the lack of some knowledge or so.
Right. I like your answer here about this, the stage of the knowledge that you had at the time when you made decisions. I think it's like we often forget about this when when engineers join the project and they look at something and they say, well, that was obviously done incorrectly. That was obviously wrong. When in reality, more often than not, there were smart people doing some decisions. They had limited knowledge at a given point in time. And they did, the best they could at a given point in time with the knowledge that they, could get. So yeah, that's an interesting point. Now, before we go, because obviously we wanted to talk about how do you deal with the tech debt, how do you remove it, or how do you refactor the application, or whether it's worth to refactor it. I think maybe first we'll talk about how do you measure the tech debt in your in your code base or in your technical product, as the first step in order to figure out what to fix, where to invest your time and money, you surely have to some way of measuring or assessing, particle areas of code, in the context of the technical debt.
Yeah, sure. We have so. And first, again, I don't think there's a single number, like we have tech debt of 10 or so, and we have to go down to 5. So I think you have to take multiple measures or metrics or things into account. And what we do is, or I do, I see there's 3 categories of ways you can measure it, right? The direct ones, like evaluating on the code. The second is more like measuring the whole development process, measure and see if there is any connection to the tech debt. And the last one is about, talking to people what their mood is, because this sometimes also has a good connection to it. So I can jump a little bit into those topics. So the first one, what we do is kind of a hotspot analysis, right? So when you look at tech debt, right, it's all about slowing down changes or slowing down future changes. So what first thing you have to understand is what changes very often in your system. And it's not only maybe the code base, the code itself could also be infrastructure nowadays, right? So we what we do is, and you can easily do this with Git or so, check how high is the change frequency of several parts of the system. And then once you know this, you have to understand is it difficult to change or not? And therefore we use, default tools like SonarQube. I think this is very well known, and they have what we completely use is this metric of cognitive complexity, though it shows how complex is this code to understand and to change. And when you put it on a graph or an axis, then you get a nice graph, and you see everything what is on the top right. This should, really take some attention and should be reflected maybe in the future. So this is this direct approach, right? And
so just to, before you jump to the second point, what you're saying is that one thing is the cognitive complexity. That's the one sort of the axis, and the other is the frequency of change. So the idea here is that you want to look at things that are changed often, and they are difficult, that are at the same time difficult to cognitively comprehend, because you don't want to invest your time in things that, even if they are complex, they are readily changed, and they don't bring much of the return of investment.
Yeah, exactly.
Correct?
Yeah, exactly. So because if the code is running, has no bugs, but is really ugly to read, then it's not really important to refactor it, right? Some people would love to refactor it, but because everyone wants good code, right? But it is, from the business point of view, it's not really necessary. And if it is, yeah. So yeah, you're totally right.
Got it. Makes sense.
Yeah. Okay. And for the next point, it's like, let you monitor and to do this anyway, your software development process and whatever approach you take there, right? We take a look at the star metrics, so we try to deliver as fast as possible, as often as possible, and keep changes small, right? And whenever something there drops, like the deployment frequency or the lead time to change, it could be a good indicator that there might be something wrong from the technical side, like you have to refactor the pipelines or so. On the other side, this is also, risky, because sometimes it's always the most easy choice to say, yeah, this is tech debt, or this is something the technical team has to do. And sometimes, it's more complicated to fix it because it's kind of a cultural thing. So you can use it, right? But you have to take and do this with care.
Got it. So in that case, you are looking at the things, or the in the dynamic perspective. So because you said that you are looking for the drop in certain metrics like DORA metrics, so you see that there might be a chance of tech debt being introduced in the recent changes.
Yeah, exactly. Mm-hmm. And the last thing is not so direct, but I think it's very important. It's about, in all those conversations you have to check how people talk about parts of the system. And this is also important. Like if people, for example, we have this with the pipelines, they are super slow, and you heard from different corners and from different people, then it might be also a very good indicator that you should refactor in. And for me, even even if it not directly affects the business or makes the process faster, it's very important that people are, you like to work with in the environment. So it's important then sometimes to also say, yeah, let's improve this, right? So the work is more smooth. So this is the third and most indirect matter, I would say, how you can measure this tech debt.
Mm-hmm. So it's more based on a feeling and sort of a morale of the team working on it.
Exactly. Yeah.
Which is obviously an important thing, obviously, there's a lot. I think I found sometimes that the sort of the how motivated obviously the team is impacts the performance, and sometimes even a tiny investment in certain area bring a lot of, well, for the lack of the better word, joy to the to the engineers and the entire team that finally something has been resolved. That might have only this didn't affect the business entirely, but affected the sort of the mood and feelings of the development team.
Yeah, exactly. I mean, there's also some risk, right? Like of over engineering or bringing everything to perfection. But sometimes it's also important, that people want to be heard, and as you said, right, to raise motivation, and it's more fun to work with it.
Right. Which brings us to another aspect, because as you said, there is a danger of over engineering. And I think in most of the teams, at least from my experience, there were always many different candidates for the areas of code to be refactored. And when you looked from the business perspective, and you put a businessman hat on you, and you think only from business perspective, apart from the motivation, it was, at least for me, it was very difficult to assess the return of the investments, because my reality was, and the reality of people that I talked with about this problem, is that most of the time it took significantly more time to actually fix the technical debt that it seemed at the very beginning. And that included obviously the time to refactor the piece of code base, but also the thing was that more often than not, it also brought another bugs and another defects to the software. And often, or at least sometimes, there was a long tail of those bugs that had to be fixed, that were introduced in the first place because of the good intention of improving the existing code base. So from that perspective, could you elaborate a little bit more about how do you approach this ROI, right? You mentioned this two axes and where are the hotspots of things that you want to fix, but probably you want to have some sort of the estimate, whether that's worth it, whether at the end of the day it's gonna be it's gonna be profitable to actually spend some time on this on this piece of code to refactor it. Could you tell us a little bit about that?
Yeah, mentioned it partly, right? So first thing is, of course, you have to know, right? Whenever you change something in the system, is some tech that's connected with it, and it doesn't make sense now to tackle this topic, and then it only makes sense, right? Because the system is changing, and tech debt is in your ticket system all the time, so you can't just estimate all of them, but therefore you have to know, okay, this could be tackled now, and then you have to go into, as I said, you have to understand what's the impact of this, of fixing this, or of not fixing it in the current scenario. You make an estimation, you talk with the business about midterm goals of this functionality, and then you can derive a good estimation. Does it make sense to fix this now, right? And so at least you have the business side of it. And then I'm a big fan of doing this incrementally. So not doing this big bang refactoring and refactor everything. And that's why this hotspot analysis is really valuable, because you can see, okay, to what degree does it make sense to refactor this? Let's start with the most important things, or the most valuable things, and then see how this evolves. And then so you can apply the same pattern you use in software development in general also to this refactoring. Just do small steps, and maybe this helps already a lot.
Hmm.
So this can remove the risk of over engineering, because you have steps and steps and steps, and
Did you find yourself at some point in time in a situation that it was unless impossible or at least very difficult to make this incremental refactoring, and you had to do completely rewrite or some other approach?
um, not myself, right? But as I said, or in the beginning, I was participating in two big projects where the whole thing was stuck. At least one of them was stuck because of some version updates. So this was not so much because the code itself was, or the code base itself was in some kind of state where it could be further developed with acceptable costs. It was more like that the vendor, it was a migration from a closed source project to an open source project, and the vendor had just updated the software to a new major version, and the update of this for this project and all the customization would have been so expensive that it didn't make sense anymore. So this was the time where I will. Well, it was where the company was unable to maintain this anymore for myself, not right.
Right. So
Exactly.
the answer in that case was sort of the restarting the project and doing it somewhere on the side from the very beginning with the new architecture or the new
Yeah.
updates.
Yeah, exactly. So the decision was to check how far that when it initially was used this tool. So the open source community wasn't that far. There wasn't that good solutions, and then they revalidated it, and so the costs for using this a more common technology was strategically much better, because it was you saved cost, and from the people side there were a lot more developers who could work on this, because this was not so highly specialized as the original project. So it was a really strategic decision there.
Got it. Right. So from the operational perspective, when we talk about, you already hinted at that already about these incremental approach, but maybe we could dig deeper into the approach of solving the technical debt. And I'm interested really in two particular sides of it. So first is, how do you approach it from the technical perspective, or any tools? You already mentioned SonarQube, so that's one thing. Maybe there are others, some tools that you use, some engineering approaches that you use, and maybe some things like, I don't know, canary releases with two versions running at the same time, some rollback strategies, things like that, depending on the nature of the problem, obviously. So that's the one side of the question. The other side that we could dig into later on is the organizational or the management perspective or management approach to sorting out the technical debt. And I'm thinking about things like, some people choose to have, like, we'll do the one iteration if we are following, for instance, some Scrum methodology. We do one iteration when we focus entirely on tech debt. The other organizations or managers have this approach, like, let's spend, I don't know, 20% or 10% of our time for the whole the time to consistently and constantly try to fix the tech debt. So let's start with this technical, I think, engineering and technical approach to fixing tech debt. Any pieces of information about that area?
You mean like tooling, right?
Tooling, yeah, and approach, as I said, like things like canary releases, some rollback strategies, things like that.
Mm-hmm. Yeah. This is, for us, it's highly connected, right? And it's a little bit hard to differentiate. So leaving out the broader context, we use for tooling, and this is mainly for not adding up more tech. That is what we use is different approaches. The first one is that we have code reviews, right? So even if, for example, a junior developer does some stuff, and it's always that the second developer has to check what's done there. And this is not about blaming. It's really about improving and getting a better understanding of the overall architecture of the system, and also the requirements of the business in this case. So this is one very important thing here. And on the second thing, if things become bigger, we do the same with architecture decisions. We always write down every decision in an ADR. And once this thing is written down, everyone has to at least check it. I mean, who's kind of touched with it or who's just interested. And as long as there are as long as there are strong objections against it, then it is not accepted. So then the discussion goes on, right? So we reduce the risk of making a wrong architecture decision. That's what we do on the organizational side. From the tooling side, we don't. I've never tried real tools. I know there are some outside, but we just use this SonarQube, for priority and everything else. We use I could only recommend to use the best IDEs, right? Because they help a lot. And of course, nowadays you can't avoid it, right? It's all this AI stuff because it helps a lot of doing easy refactorings. I mean, at least if you don't do complex stuff. So.
So this is more of a approach of preventing the creation of the technical debt in the first place, right? What you said about the reviews, making sure that that you don't introduce it into the existing code base.
Yeah, exactly.
What about the this management or organizational approach? Is there anything specific? How do you approach this thing?
Yeah, this is more or less where this is all embedded. So as I said, I really appreciate the approach to gradually deal with tech debt, because I think this as you mentioned, this sprints where you just have to do tech debt, it's really demotivating, and sometimes it also introduces new tech debt, and then you might end up with just different tech debt, right? So our approach is that we have or try to establish a culture of ownership and responsibility for the code. So it's not just if you have to implement a new feature, it's not just that your job is to implement this feature with good quality. It's also to have a look on the left and on the right, and if you see anything you can improve, then do it. So that we don't have a fixed amount for this, like 10 or 20%. It's more like, okay, everyone has a good idea about the code he's dealing with, and then he can, if it is to a certain amount, he has to fix this, right? And same as with bigger things, then this ADR approach comes into account, and people write this down also during implementation. And this way I found that it takes away this special feeling about tech debt. So it's normal day-to-day work. And for those bigger things, maybe because so now we have in the system, regularly we have regular meetings where we discuss about those things, how much urgent they are now, and so on, and then we decide what to do with it. But again, we always try to not do a big bang refactoring, but also how can we gradually introduce this to the business or to the product, so we can slowly switch, like what we did now is, for example, we changed the whole architecture from a more the front end API architecture. So before that, we were proxying everything into this, and now we introduced a more gateway approach. But we not did it for all our services or in one big bang, but we do it gradually, like for every service.
You as far as I understand, you you respond to the CEO of the company, so we need to also justify those investments in fixing the tech debt. Did you find it difficult in the past? Did you find some strategies working better than others? For instance, like I mentioned before, a fixed amount of time that is spent consistently on the technical debt, or you just if you have a big chunk, especially a big chunk of work that is related to technical debt, you just divide it into pieces, and usually you didn't have any problems with with justifying this investment to the management?
Especially in the beginning, right, when I was arguing more about the benefits this technology has. And what I've learned is that the key here is really about, business impact. So what value does it have? And even if it is a bigger chunk, changing from one technology to another, then you have to translate it into this language the business understands, and this is always business impact. And I mean, at the end, from my point of view, you cannot just the technology just because of the technology, right? And you must always name the reasons behind this, right? And if it is only like we can't find any people who can maintain this anymore, this might also be a strategic reason, right? But this is then not because the new technology is cooler, and this is often the case that sometimes people tend to talk about the benefits of a certain technology, but you can't do this, right? If you have, especially if you talk about bigger chunks, because this is always about an investment, and always people want to get something back from it.
Mm-hmm. So, but it seems like a tall order in general to justify it in a reasonable way. At least that's my experience, because when you fix something, when you try to fix something, you see the burden that it has today, and that's clearly visible today. You see how it is in terms of people motivation, finding people that want to work with it, and even speed. What is unclear is the amount of time that is gonna be, that's gonna take to fix a given thing. And the other thing, what is unclear is how much will it improve the given situation in terms of the motivation or, for instance, speed. So this, I think, comes down to how do you reliably estimate the impact of the given thing in terms of the, coming back to this ROI and as you said, the explanation. If you say that, we're gonna fix this thing and it's gonna improve the speed of introducing new features, for instance, which are affecting the business. Did you find it difficult in the past? Do you have some ways how to assess it in terms of the what would be the outcome, what would be the benefit? It seems to me like it's a difficult thing in general.
Yeah, it is, definitely. And again, what you have to do, you have to find some business partners who really helps you transforming the near-term future ideas, this whole what you can do with it, right? And not in a technological way. What does it mean for the product? So of course you can estimate how much will it take me to replace this chunk of code or to fix it, and you can also hardly, but somehow have an idea what does it mean in terms of the processes you have to change and so on, or the monitoring, whatever you build around this, right? But what is important is what does it mean for the product? So what perspective do you have if we do this from the product side, and so you have to find some companion in order to argue about it or to win these discussions. So again, I mean, it has changed something. So the tech departments are no longer only a cost center, right? They also are there, in order to enable the business, to bring up new features, and this is more where I think you should act, not so much and always, in this. We need some money. I'm sorry, we messed up, or so. It's more like, we do this now. So this means this for our product, for our business. So this is more the direction I go there.
Got it. Well, I guess, it depends on the business. I think in your case, when the goal of the business of Corify company, as far as I understand, is building the digitized market for the insurance, the nature of it is pretty much technical. Yeah, there are many other businesses that for which the technical part or the technology is, as you mentioned, the cost center that allows to do, often the physical business, for instance, right? So, I get it. In which case it might be a little bit more difficult because it goes back to the awareness of the senior management and executives of the role of the technology in business.
Yeah, exactly. I think so too. But this has changed, luckily, at least, right?
Yeah, definitely. I mean, like, it's difficult these days to imagine a new business that is being formed that is, all the businesses rely on technology more than in the past. And I think this awareness is becoming more and more widespread. So from this, did you have any experience, for instance, what I saw in my experience, in others people's experience, is that there is a chunk of work that is a technical debt, and we know that it's bringing some problems. Maybe it hampers the velocity of development. Maybe it brings down the motivation. And we decided to tackle it, probably not picking too many battles at the same time. So wanted to pick one or two things and then spread it over, some periods of time, maybe a quarter or 2 quarters, and divide it into manageable chunks. And sometimes what happened is that, we sort of thought it's going to take a quarter, few tasks here and there. In the meantime, doing some new features that were requested. And the quarter has passed, and we realized that we are nowhere near the end of, fixing what we were intended, what we planned to fix. So did you have any experience with such situations? How did you deal with them?
For me, this is also an iterative approach, right? And if you say, you want to do this and that, different chunks of code in a certain amount of time, then you still got some value by just doing the most important one, which you started with at the beginning. So I was never in this situation where, then it's okay to not continue with the things planned, right? So yeah. So not really, right? I told you from those 2 projects, but those were more like, migrating those big code bases, and there was a lot more stuff, and it took much longer. But this was a whole different approach, because I've never experienced something like this where you had small chunks and you didn't finish it. So, and at the end, to be honest, for me now it wouldn't be that bad. So because at least you have finished the most important ones.
Uh-huh. So that is at least, one sort of the piece of advice that comes from that. If you divide it into certain chunks, be sure that you pick the most important ones at the very beginning, because even at some point, it happens that for some reason, either the stakeholders or the shareholders of the project lost patience in a way to invest in that thing. At least you fix the most important thing. You don't have to finish everything. If you fix like 60% of the pain, it's still 60% of the pain alleviated, which is still a success, right?
Yeah, or maybe it's even more, right? If you prioritize right. So yeah.
Right. So do you have certain areas, or do you have an experience with certain areas of the code base that that this is a messy code base? There is a lot of technical debt. No one wants to work with that, but that it's very low on the priority list, and some people are not engineers are not motivated to work on that, understandably. Do you have experience with such areas? How did you deal with that? Is that's just the fact of life. Then in most projects that are just mature enough, it's gonna be some place which is, it's not easy and not fun to work with, and that's just the fact of life. You have to deal with it.
Yeah, you're right. The question is, is this in one of those areas which has to be refactored, and now let's imagine it is. Then what I found out is that it is most important to give everyone the chance to really change it, right? And not just to have to work with it. So this is maybe the difference. So sometimes, you want to change it, and then, you have to say, yeah, but business doesn't want you to change it now, right? And they have to go on and go on and go on. And from my point of view, as a tech leader, you have to prevent this. You somehow make sure that everyone gets the chance to fulfill this responsibility I talked about, and really have the chance to change it. And then it is not so bad anymore, because you have to change the code, but you know better, and you have the chance to change it. And this brings somehow back the motivation and to the people. But I think it's really worse if you can't change it, but you want to and have to work with it for some reason.
Mhm. Got it. So maybe coming back to this original one of the first questions that we had at the very beginning about the good and bad tech debt, and the tech debt being the result of the conscious decision of the trade-off. Let's say that you are making this trade-off and you are choosing a certain piece of the of the software that you are building to be suboptimal. Do you have any techniques or advice in terms of how to contain it? You know that you are going to do a suboptimal work. How do you prevent it from spreading over all other places or being unmanageable in the future? Do you have any experience with that?
What do you mean exactly?
Like what I'm thinking is that in many organizations, or that was at least my experience, is like you work with something and there is a pressure to deliver something. The pressure makes it so that it's very difficult or impossible to do a good engineering work, so you make some sacrifices. The problem that often is that's as they say, sometimes you make those sacrifices and they are in a way eternal. You never got back to it, and you just created new technical debt that is unmanageable in the future.
Now I understand. Yeah. For me, that transparency is key, right? So you have to make sure that everyone knows, okay, we have a certain amount of tech debt in the system, meaning we helped, to deliver as fast as we can. But we also have to make sure that we can, pay back the tech debt or the debt. And we do is like we whenever we see there's a new feature to be made, and we do this decision as you said, and make some compromises. We write it down into a ticket, and you can't really estimate it now because the system is changing. But what you can do is you can at least, and this is mandatory for us, put a rough t-shirt size on it, say okay, this is really a big chunk and we have to do this. And you also have to write down, how does it affect the system, and kinds of impact for the business. So, for example, what is nearly a no-brainer is if you say, yeah, but we have to fix it because otherwise we will have continuously some security things, for example, or this and that, and with this. Two numbers, the impact and the size, you have to make transparent, and then of course, at the end, if someone decides, I'm not still interested, but that's all you can do, I think, to make really transparent what the code base looks like and how sustainable it is.
Got it. So it's again a conscious decision made up front, right? Is there something like a broken window theory of the technical debt? Like the broken window theory is like, I think that's the economic theory that there was a broken window, and when people found something that was unmaintained as a broken window, they were more eager to start littering around that and not care about the general state of it. So what I'm saying is that you have a certain piece of code which was maybe even deliberately suboptimal, and it was written in a bad way, and then it spreads because people start to build on top of it another thing, and given the shaky state of this piece of code, it gets expanded, and it's even more difficult to handle it in the future.
Yeah. I mean, if you miss this, what I've said, right, that all this, the refuse and so on, then I think this might be a good candidate, to rewrite this whole functionality, because if the base is so unstable that everything which is on top of it, you have to change anyway then, right? So not.
Mm-hmm. So it's again sort of the responsibility of everyone in the system, and you rely that of people reviewing the code base and trying to put some checks in place to avoid the expansion of these of the technical place from one place to the other.
Yeah, exactly. I mean, you should notice, right? Sometimes you don't, but at least it's not. If it is only, as I said, if it's not changed very often, it cannot become such a risk, right? But if it is, then you have again and again these reviews or these mechanisms to check it, and if you monitor the stability or the error rates, or whenever something is changed in this piece of code, and it takes every time much longer, then of course you have to be alarmed and check this again.
Got it. Do you find any differences in terms of the effectiveness of using the AI tools for development in the legacy code bases, or the code bases which are written with technical depth, comparing to the other ones which are the maybe more stable, more properly engineered? I'm talking about things like Cursor or Copilot. Do you find it effective in your production code bases?
Yes, definitely for the easy things, right? So it helps, if you have recurring things you have to build again and again, then it really helps, to be much more productive, right? You don't have to write the 24th controller or persistent structure in easy cases. That helps a lot. So first, second is that it also helps, and maybe then we have this connection to the legacy code base that helps to explain even complicated code passages, right? Not the whole architecture, and especially not the function, but it helps, to understand single functions, for example. So that helps a lot as soon as we use it for now.
Right. And what tools are you using as of today?
So Copilot we used, and so for the rest, the guys are relatively free, right? As long as it is not like shipped to some China or so. So we use Cursor, we use Cloud Code, and I don't remember the third tool, Windsurf, I think it's called.
Well, yeah, Windsurf.
Yeah, we use those tools.
Right. So maybe so I think we touched a lot of different areas. Maybe before we wrap it up, maybe you could tell us, if you were to give 2-3 sentences of advice for an engineering manager or a CTO that maybe joined another company and has to deal with the code base littered with technical debt, if there is anything that you would advise such a person.
The first one is really what I talked about, is this trying to make tech debt as the day-to-day business work, and then the job for you as the tech leader is to establish this culture, really make everyone able to fulfill this responsibility and take care of the code, so it becomes more part of the daily work. So this is basic for me. And the second thing is, and this might sound a little bit different, is that you should sometimes be bold and just delete old tickets in the system, because if they don't appear often, then they can't be that important, and if they are really important, then they will come up anyway, and so you get some air to breathe, right? So and really focus on the important things. And the last one, I stole it, but it is more important than ever, is like, this stay hungry, stay foolish, because this AI is changing everything so fast. So if you don't have an eye on this development, I think you will lose track and fall behind very fast.
Yeah, that is an interesting thing. All of what you said was very interesting, but the last thing, it also, sparked one of the ideas in my mind. Maybe in not so distant future, maybe dealing with the technical debt would be entirely something that could be postponed, because at some point, maybe the AI would be able to rewrite certain pieces of software in a more, in a more maybe well-defined, better defined way, or more according to the, to the sort of technical specifications / architecture. And I'm talking about this specifically because I've talked with several business technical leaders recently who had, a big refactoring technical, debt in their project. So big, in fact, that when they tried to assess, it was like, it's going to be 2 or 3 years of work. So we are unsure whether that's worth it. And at the same time, we see people are very unmotivated to work on this. It takes hell of a lot of time to introduce new features. But then if you put this, 2 or 3 years of work, it's a lot of time. And when I think about it, I don't know about your opinion, but when I think about the estimate of 2 or 3 years, in my mind, it might as well be 5 years. Who knows? It's very difficult to assess 2 or 3 years of work, right?
Yeah, exactly. I mean, it depends on how good you know this code base, right? But normally, you start working on it, and I've never seen it differently. That you learn more about the system, and normally it takes long. So yeah, I think this makes the decision even harder, right? No, I mean, maybe they already estimated 1 year, and said 3 years because they know, right? But I don't know.
Right.
Yeah,
sure. So, do you think it's gonna be? Is it something that you foresee in the future, that such refactorings or rewrites? Because this is often, moving something from one, old technology to the other. You want to have it more or less functionally similar, but for some reason you use very outdated technology, and maybe you want to move. Let's imagine you have a custom orchestration software in your organization, and you really think these days, well, if we moved it to Kubernetes, at least it would be standardized. Like, there are many different problems. Like, you have, custom software, which is difficult to maintain because no one knows it. Only in your company is being used, so no external people know it. It's difficult to recruit people. Then there are a lot of different bugs that needs to be fixed by yourself because that's your proprietary technology, and all those other things. So in that case, it seems like it's maybe not automatic, but it's something that you want to keep similar features, just move it to replatform it to something else. You think in a foreseeable future, I'm talking about 2-3 years from now, would it be something that might be doable by AI tools?
Yeah, I have two different views on that. The first one is that it will definitely enhance and become better and definitely change the way. I mean, we see this now already, and the second thing is more like I'm wondering if will be 3 years, but what will the code base of the future be, right? Because for me, it's like today, in a very simple way, like you have the business, they have some problem to solve, and they go to developer, and they talk about it, and then they find a solution, and the developer then translates it to some high level language, and then the machine can somehow execute it, right? So you always have steps, and now when really the AI can do this translation of the code base to another technology or code base, and I wonder it somehow whether the code base will be really something only a developer can understand. You know what I mean? So I really wonder. I think this that if this really is possible, then I think we will have more like something like deterministic prompting or extended prompting, where business and someone more technical work together, and then I don't think that we will have this languages anymore, which only the developer can understand and read. So
yeah. It sounds like from what you're saying, it sounds like a more distant future. Like it doesn't sound like something in a that happens in 2-3 years. I think like the progress in technology is really amazing in general, but then at the same time, many things really takes years, right?
Yeah, actually, we're in the top of the bottleneck case right now, so really it comes now. But still, so I think it will help, right? But what I wanted to say is if the AI can really, put everything from one code base to another, then we are less. Then it is so far developed that it somehow can understand the whole business, and then we are on this stage more. Yeah, I can totally see that.
Right. And realistically speaking, I've put this question in a way that I framed this question in a way, moving or replatforming from one technology to the other, keeping the feature set, the same. But realistically, it's never the case. Whenever you replatform something because of some technical constraints and because of how business changes, you usually do it a little bit different, even from the feature perspective, even from a little bit from the business perspective, right? At least that is my experience.
Yeah, I mean, you make technology choices based on some business requirements, right? And so if you choose a new technology, then some things will be done differently. I mean, and you don't want in either terms, you don't want to write, I don't know, Java code, or if you translate Java code to Go, you don't want Java code and Go, right? You want Go code, and same as, so you would not you can run a monolithic architecture in a Kubernetes cluster, but does it really, bring all the advantages this has to bring? And so this is really hard to do by an AI today, right? Because this is so connected to the business and all this context.
Right. It's like the business impacts the technology that you pick, but also the technology that you have sort of impacts the how the business is working to some extent.
Yeah.
All right. So I think we may wrap it up. It was a very great experience to have you here, and to pick your thoughts on this topic of the technical debt. And thank you for being here, and hopefully we'll have a chance to meet together again at some point and discuss other interesting topics.
Yeah, I would really appreciate it. Really, thank you very much for having me here again. Thank you.
Thank you.